嗱，呢一條專訪片咧，我特別想拍個 intro 啊，因為呢一條專訪片咧係我咁多條專訪片裡面嘅時間最長啊，差唔多成14分鐘。咁我盡量一般嚟講係唔會拍一條專訪片係剪到有14分鐘嘅，就算佢講14分鐘，我都會剪到得返4分鐘。但係今次有關呢一個專訪嘅內容咧，其實比較技術性同埋係技術嘅研究多過產品嘅推廣。咁所以我想即係俾一啲有興趣知道嘅朋友咧，全個訪問嘅內容都可以睇晒，咁就係呢個瑞士 PSI Audio， 咁亦都係我呢一對喇叭嘅品牌啦，亦都係我之前其實都用過5年 A25M 佢哋嘅旗艦嘅 Studio Monitor， 咁所以我都好熟悉佢哋背後嘅理念啊，咁啊特別咧係有幾樣嘢我係好想問呢個 PSI Audio 嘅 CEO Roger 嘅。咁第一個問題就係一般好多歐洲嘅 Studio Monitor 都開始做呢個 DSP Digital 嘅喇叭啦，咁但係佢哋係堅持啊係 Analog 嘅 Studio Monitor 嘅。咁第一個問題想問呢樣嘢啦，第二個問題就係問佢哋咧大部分嘅單元都係買翻嚟嘅，咁但係淨係旗艦嘅 A25M 嘅高音係自己做，咁我想問佢即係點解一定要自己做，因為自己做其實成本貴好多。第三咧就係佢哋嘅擴音機，佢哋當然係即係每一個單元都有自己擴音機啦。咁但係個擴音機係用Class H 嘅擴音機嘅。咁我又想問即係佢點解用 Class H 啦？第四個咧就係佢哋有一個好革命性嘅產品，就叫做 AVAA， 係一個主動式嘅 bass trap 嚟嘅。個 size 唔大，但係佢係會發放一啲頻段去將房間嘅 room mode 抵消。咁呢個係一個好革命性嘅一個產品嚟嘅，咁所以我亦都想佢講一講究竟呢個產品有啲咩背後嘅理念。我淨係問呢個問題都講咁多啦，咁佢亦都答得好詳細。咁對呢一個方面有研究嘅朋友咧，真係值得去睇一睇呢一條長達14分鐘嘅訪問片。我哋即刻去片。
So, well, thank you very much for having me here today. My name is Roger Roschnik, and I'm from Switzerland, and I work for PSI Audio, this company here. So, the company was founded in 1977, so 41 years ago, by Alain Roux, who's now retired but still very active. And his idea was that a speaker has only one single role, and that's to transform an electric signal into an acoustic signal, and as accurately as possible. So he developed speakers with this scientific background and with measurement instruments, and little by little he improved the quality hand in hand with the measurement instruments. And so made first passive speakers, so with no amplifier inside, for hi-fi use. In those days there was not a big difference between hi-fi speakers and studio speakers, so they were also used in studios, broadcasting. Then he developed a range of PA speakers, so where the aim is to be loud and robust, so very big speakers. And then about 25 years ago or 30 years ago, built a factory in Yverdon in Switzerland, Yverdon-les-Bains, to produce speakers that we developed for Studa. So we developed active speakers for Studa, and that we manufactured there. So for the last 25 years we've been making only active speakers that we made for Studa for 10 years, and then Studa was acquired by an American group, and they no longer wanted to sell speakers anymore, so that's when we relaunched the old brand PSI. So PSI is 40 years old, but we had a break where we only made Studa for international sales, and now for the last 10-15 years we make PSI again. You should think of what a loudspeaker is supposed to do, and for us it's to transform an electric signal into an acoustic signal. Then you need to amplify the signal, and it's best to have an amplifier that's perfectly adapted to the membrane it's driving. So it's very good to have one amplifier perfectly adapted to each way of the speaker. So this is why we build the amplifiers directly in the speaker, and that's an active speaker. It's more efficient, we find. It's like having a car. The engine's inside the car and perfectly adapted to the car that it's supposed to motorize and drive. So that's the first thing. Then you need a few things. You need to send the high frequencies to the tweeter. You see the low frequencies to the woofer. So you need some filters here. And then you need phase compensation for the phase to be exactly the same from the input signal to the acoustic signal. So all this you can do in digital way or analog way. In the 90s, we looked at the advantages of digital technology, and the summary was that digital technology is great if you want to memorize information or if you want to process information. But for a speaker, nothing's going to change during the lifetime of the speaker. You're just going to input an electric signal and output an acoustic signal. So you don't need to memorize any information, you don't need to process any information. You just need the transfer function, and this transfer function can be set into analog technology quite easily. The problem with analog technology is this transfer function has to be done with electronic components. So you need a very tight control. Well, first of all, you need a very smart architecture of your print, so you minimize the amount of components, and then you need a very tight control of every single component that goes on. And of course, it's very easy to want to do this with digital technology because you can just change all the filters and all this with a keyboard. So this is why lots of people have gone down the digital road, but we find that it's still better in a speaker to use purely analog technology. Most of our customers that are professional users, they like choosing their digital analog converter with great care, and they like choosing it. It's a key element in their workflow. You don't want afterwards to have another double conversion inside the speaker. So you don't want to come in analog in the speaker, convert this to digital, do a few corrections, and come back into analog. It makes totally no sense to have a double conversion inside the speaker. This is why we on the speaker part, we want to remain analog as far as possible. Everything we want to fix everything you can do in the analog world with analog technology. Most people think the driver is what makes the sound, which is true, but what's important is the way it moves. So you want it to move properly. So first of all, you need a very good design of the driver. It has to be perfectly balanced, because it's a mass on some springs, and then there's the material itself. So you want this to be designed the most rationally possible for a start. And you don't find many drivers on the market that are designed really properly. The other thing is with active speakers, all the damping you can do electronically. So we do this with a feedback loop. So all the damping we do with our amplifier, with a feedback loop that controls the movement of the membrane. So you want the driver to be very well or very rationally designed, and then very simple, okay? But then what's important is that it should be very regular in production. Now for a woofer and mid drivers, you can find the manufacturers that do that, and we have a few manufacturers that manufacture these drivers for us. For the tweeter, we found no manufacturer that could do this, so we make it ourselves. It costs us a fortune, but there's no other solution. So we do all the winding, all the design is ours, of course, like the others. The winding of the bobbin, the coil, magnetization of the magnet, the mechanical assembly, all has to be done extremely accurately. And there's very little chance that there's another tweeter anywhere else on the market that performs as well as ours does. This is why we do it ourselves, and we often develop prototypes and test a lot of drivers and different driver types, and we come to the conclusion. Now every single so once you've got the right design of a driver, then you have to keep the manufacturing very stable. So each time we outsource any manufacturing, we have to check every single component when it comes back. So we do 100% incoming inspection, where we check in an anechoic chamber the performance of every single driver. This avoids having to correct or cheating with things later on. Class AB is considered one of the best amplifiers, or the cleanest amplifiers. The problem is that you supply a certain tension level all the time, and when you don't need that power, that tension, all of the extra power has to be transformed basically into heat. So it's not very efficient, it creates a bit of distortion, and it also creates a lot of heating up of and thermal stress on the components. Now Class G, or it's actually Class H that we made, but it's GH, it's very similar. We use different tension levels. So you'll use the low level tension, and seamlessly you'll go to a higher tension level only when you need it. So you're only using the power when you need it. This has the advantage of, it seamlessly navigates between the tension level, and it has a better efficiency, and this doesn't create as much heat, so it has less thermal stress and less distortion over the components. What's difficult is it's quite difficult to be able to design these, and it's quite difficult to manufacture these. That's why not many people use them in audio. But we also developed amplifiers like this for Swiss precision mechanical industry that use our amplifiers, not only in audio. The same with the tweeters we make. We also made seismographs. So many bridges in Europe use our seismographs that are made with the same technology as our tweeters to measure vibrations in the bridges. What's coming direct is as accurate as possible so that it resembles the source. If you want to listen to a piano, it has to be the same as the piano. But then you put this in a room and you hear all the echo from the rooms. That's the first thing. And this contributes to you understanding in what environment you're in. Now you want it to be quite balanced. You want to feel as if you're in the right kind of environment. So it can be a church that resonates a lot or a studio that resonates a little bit. But you want it to be balanced. And in a studio or in a place where you listen to lots of different types of music, you have to have a resonance time that's quite low. And this is very easy absorbing medium and high frequencies so that the resonance time is low. But for low frequencies, it takes an enormous amount of porous material. So we've been thinking for at least 25 years, how we could use our active technology not to make sound, but to absorb sound. And we managed to do it in an efficient and stable way. And the first thing I'd like to say is that it's not noise cancelling, it is real active absorption. Now, I can try and illustrate this. If you have sound is pressure going up and down, okay? Like if you're swimming in the sea, you've got the waves going up and down. But you also have movements of molecules going back and forth. Like when you're swimming in the sea, you also tend to go back and forth. Now this, if you think of this movement, when it comes against a rigid wall, it'll stop, and all this energy will be transformed into pressure. It has nowhere else to go, like crashing waves against the wall. And this will create the echo that will come back. So it's this velocity that you want to avoid transforming this velocity into pressure to create an echo. So there's two ways of doing this. Either you can slow down the velocity, so you put porous material that will slow down by frictions, but then you can imagine that when you've got very long wavelengths, you need a very big, up to several meters of absorption porous material. The other thing you can do is to move the wall so that it's in sync with this velocity and it never changes, a bit like when you amortize a tennis ball. You sort of move back with your racket the same way with the wall, okay? So you can do this. So this is the principle that we have in our AVA. And now it's difficult moving a wall completely. So what you can do is move a small portion of the wall, but displace the same amount of water or air. So you should imagine displacing this amount of water, but over a smaller area. So you'll be moving back and forth a lot more. So you'll be increasing the speed of this, which means reducing the acoustic impedance. That's the ratio between the pressure and the speed. So you can imagine how a small surface can have an effect much bigger. So this is what our AVAA does. It's basically imposing a very low acoustic impedance in front of it. So the AVAA is 0.2 square meters, and it absorbs as much as 25 or 30 times its size, frequencies between 15 and 150 hertz. That's what it's designed to do, and that's what corresponds to most of the room modes in normal size rooms. So we're very proud of this product. First of all, because we have to be very quick in the processing of information, and this we managed to do with analog technology better and quicker than with digital technology. When we developed prototypes, we developed digital prototypes because we can modify the filters very easily, but we always managed to keep it more stable and more accurate with analog technology. And also to make sure it works, we calibrate every single piece in the anechoic chamber. So yes, and it's a very useful device to treat the low-end problems in most rooms. You'll be surprised how efficient it is. And it's really pure physics, and we've installed some in boiler rooms, heat pump rooms, technical rooms in hospital also, where there's a general low frequency noise that disturbs the people working in the building. Not only in studios and listening rooms.